In the right triangle ABC, we notice like the angle B is 45 degrees and C as well 45 degrees, which means like the sides AB and AC are equal. But in this case, what is the trigonometric ratios of the angle 45? How can we get them based on the right triangle? So to find them, if we give a length of AC, for example, equals 1, we can see that AB must equal 1 as well, because ABC is an isosceles triangle. And we can calculate the value of the length of CB using Pythagoras theorem. So to do that, we can write like AC squared, which is 1 squared, plus AB squared, which is 1 squared, equals BC squared. And therefore, BC equals square root of 2. So we can write here the length of CB equals square root of 2. Now it's easy to find the trigonometric ratios of the angle 45. So we start with the sine. Sine 45 degrees equals the opposite divided by the hypotenuse. So it's 1 divided by 2. By square root of 2. Cosine 45 degrees is the adjacent of the angle B, I would say here, which is also 1, divided by the hypotenuse, which is square root of 2. The tangent of 45, so if we take again the angle B, is the opposite of angle B equals 1, divided by the adjacent of the angle B, which is AB, equals 1. So the answer is 1. The cotangent of 45 is the adjacent of the angle 45. So if we take the angle B, is again the adjacent equals 1, divided by the opposite, which is 1. So the answer is 1. So in this way, we can calculate the trigonometric ratios of the angle 45. What about the angle the angles 30 and 60? So if we go check out this triangle, it contains a right angle at A, and the angle B is 30 and the angle C is 60. And to find the trigonometric ratios here, we need to actually do some construction. So if we divide the angle A into two angles, 30 and 60, using this construction. So here we sketch this one. Let's say like we intersect the line that we sketched, intersect CB at a point M, and suppose this angle 30 degrees, this angle must be 60 degrees because the sum is 90. And in this case, if I give a length of AM, let's say we give it the length equals 2. And since AMB is an isosceles triangle because it contains two equals angles, 30 and 30, so that means MB must equal 2. And we have the triangle AMC is an equilateral triangle, so all angles are equal since it contains two angles that equals to 60. So the third one must equal to 60 as well. And that means all the sides of that triangle AMC are equal. And therefore AC must equal 2 and CM must equal 2. And based on that, we notice that the opposite to the angle 30 equals half of the hypotenuse CB. Because here we have the opposite equals 2 and the hypotenuse, all of it, equals 4. And to calculate the third length of the triangle, which is the length of AB, we can apply Pythagoras in this triangle. So in this case, I conclude, like, for triangle here that contains an angle 30 degrees, the opposite is always equals to half of the hypotenuse. So with this one, if I say the opposite is, for example, number 1, then the hypotenuse equals to 2. And in this case, I can calculate the third length of the triangle. So if I name it again A, B, C, I can say, like, AC squared plus AB squared equals CB squared, using Pythagoras theorem. AC squared equals 1. AB squared is the length that we need to calculate, so we keep it. CB squared is now 4, because CB equals 2. And that means AB squared equals 3, so AB itself equals square root of 3. So I can write here square root of 3. This angle must be 60. And now I can calculate what is the sine of 30. Is the opposite divided by the hypotenuse. So 1 divided by 2. What is the cosine of 30 degrees? Is the adjacent divided by the hypotenuse, which is square root of 3, divided by 2. Tangent 30 degrees is the opposite divided by the adjacent, which is 1 divided by square root of 3. The cotangent of 30 degrees equals the adjacent divided by the opposite, which is square root of 3 divided by 1. So the answer is square root of 3. This is for the angle 30. And now for the angle 60, what is sine 60 here? 60 degrees is the opposite, which is square root of 3, divided by the hypotenuse, which is 2. Cosine 60 degrees is the adjacent divided by the hypotenuse, which is 1 divided by 2. Tangent 60 degrees is the opposite divided by the adjacent, which is square root of 3 divided by 1. So the answer is square root of 3. And the cotangent of 60 degrees is the adjacent divided by the opposite, which is 1 divided by square root of 3. Or you can say the cotangent of 60 is actually the reciprocal of the tangent, and you can say the cotangent of 60